Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today is the time for Decode NCERT Physics chapter. So we are going to discuss electrostatic potential and capacitance part 2. We have already completed electrostatic potential and capacitance part 1. If you have not watched that video, you can go and check that video. And how you can utilize this video, you have to open your NCERT book along with this to be able to understand what all I am saying. This is not a standalone video. You cannot understand without opening NCERT book. Obviously we are trying to decode NCERT, so definitely you have to have your NCERT book available with you. And whenever I say this is important, this part you have to mark them, whatever slightly explanation also I am doing during the lecture, so you can follow that with your NCERT book, so that in future whenever you are opening the NCERT book, you know, okay, this part I have to study, this part I can skip. Okay, so that is the main important part. I told you also today is the last day of the year, so I wish you happy new year to all of you in advance, and enjoy your new year, and I wish you to have a very successful 2025. Whatever mistakes you made in 2024, which is a long list, I know many of you have done a lot of mistakes, especially skipping classes, skipping textbooks, just joining the college for sake of fun with your friends, not attending the class, not listening to the class properly. So that time is over. Now you have to focus on your study. 2025 should be focused on study only, nothing else. Clear? Now with that note, let's start with this chapter. So let's start with the chapter where we left. We have completed up to page number 61. Up to this thing we have completed, and we are continuing with this electrostatics of conductors. From here we will start. So first of all, there are few points, very important points. All of these points are super important for MCQ questions, for short answer type questions, and fill in the blanks question. Everything is possible from these few statements, whatever I am going to discuss right now. Okay, so understand them properly. Inside a conductor, electrostatic field is 0. So inside a conductor, whenever you are talking about a conductor, inside that conductor electrostatic field is 0, right? And if you understand this, that is sufficient. If you want to study more, to understand more, you can read this text. But if you have memorized it, if you have inside a conductor electrostatic field is 0, sir told us multiple times, so we don't need to waste too much time of that. We just need to understand the first line. Okay, same goes for the second line as well. The surface of a charged conductor electrostatic field must be normal to the surface every point. So this is one of the point where previous MCQ question came, that at the surface of a charged conductor electrostatic field must be dash to the surface at every point. Okay, or the surface of the charged conductor electrostatic field and the surface are normal to each other, parallel to each other, okay, not related to each other, intersecting each other, like that. These kind of questions are asked. But you have to remember that, and we are only talking about conductors here. We are not talking about any other type of material. We are only talking about conductors. Very important. And for conductors, the surface charge conductor electrostatic field must be normal to the surface at every point. So if this is the surface, suppose this is the surface and this is the electric field, then they are normal. So electric field must be normal to the surface at every point. Okay, clear? Next, the interior of a conductor can have no excess charge in the static situation. In the static situation means you are there is no current is flowing through it. Okay, static situation is basically when no current is flowing through the conductor. In that case, it cannot have any excess charge inside the conductor. All the charges should reside only on the surface of the conductor. So very simple to understand. If there is a conductor, if you give it some charges, no matter where you give the charges will not stay inside, they will come out. Okay, they will always come out of the surface and they will stay on the surface of the conductor. They will not stay inside. No excess charge. Oh, excess charge means in the sense is that normally a material consists of electrons and protons, right. So, electrons and protons, they are cancelling each other. So, excess charge is the what? Something that charges a conductor, right. So, whatever electrons are there, whatever protons are there inside the conductor, they are cancelling each other, they are balancing each other. Now, if you add any excess charge, extra charge, that charge will surface, will move to the surface. Now, next, any excess charge must reside on the surface. This is the important line from this point, right. Now, let us move on. The electrostatic potential is constant throughout the volume of the conductor and has the same value as inside on its surface. So, electrostatic potential is constant not only inside the volume conductor, but also on the surface, same value. Whatever value, suppose inside the conductor the potential is say 10 volts, on the surface also it will have same value 10 volts, okay, and it is constant throughout inside the conductor. So, if you plot the potential graph of a conductor, you will get the graph will be like this, potential versus distance. So, suppose this is the potential, this is the distance, say small r, you will get the value like this. This is the point where r is equals to capital R. Capital R is the radius of the conductor, right. From here you can draw the potential graph. This is a common type of graph. Maybe you this part is exponential obviously. So, if you miss that 1 by r proportional to 1 by r. So, it is the 1 by r nature, but up to the surface it is constant. You have to understand that. Now, next, electric field at the surface of a charged conductor is E is equal to sigma by epsilon naught n cap. So, if you remember in our previous chapter electric field charges and field chapter, I mentioned that this is a very important formula to remember. So, this is a very important formula that you have to remember. Next, you can skip all those, this is not super important. You can read it once if you want, that I said, as I said, if you want to understand everything, every detail of it, you can read that, but most important parts are already highlighted, right. So, now next part is electrostatic shielding. This is an application of whatever you have learned so far up to point 1, 2, 3, 4, 5. So, electric field inside the cavity of a conductor is 0. Okay, whatever be the size and shape of the cavity and whatever be the change on the conductor and the external fields in which might it be placed. So, if you create a cavity like means a hole. Okay, if you create a cavity inside a conductor, okay, no matter whatever charges on the conductor, no matter what is the variation of electric field in the outside of the conductor, the electric field will always be 0 inside this cavity. That is the very, very important aspect, and it is used on various point. Okay, the effect can be made use of and protecting sensitive instruments from outside electrical instrument. So, if you create a cage, okay, if you create a cage of metallic cage, okay, so all the walls, all the floor are made of metal, okay, they are connected with each other, then it can well behave like a electrostatic shield. Whatever happening outside, electrical interference, okay, only electrical interference, everything will be protected inside that room. Okay, so, there are some certain sensitive instruments, sensitive devices which do not work if there is a lightning storm going on outside. So, they are so sensitive that you have to put them inside a protected room. That is why this is very, very important. Okay. Next is dielectrics and polarization. So, this is also an important concept. We have learned about it in our previous chapter as well, I said, but we will discuss again. So, let us see what is the basic parts from this part. Unlike in a conductor, however, the opposing field is so induced does not exactly cancel the external field, it is only reduces it. So, inside the conductor we have learned that inside the conductor electric field is 0. Why? Because you can say that there is an induced electric field. Okay, suppose the electric field is moving from this side to this side, it is electric field is moving like this. There, if you place a conductor here, suppose this is a conductor, then inside the conductor there will be an electric field which opposes the electric field, and it is exactly the same amount of the external electric field. So, internal electric field and external electric field are same. So, they cancel each other. So, the electric field inside the conductor is 0. But in case of dielectric, okay, suppose the external electric field is in this direction, the internal electric field will be opposite direction, but will be in a small amount. It is much smaller than the external electric field. So, it is reducing the electric field, but it is not completely 0. Okay. So, that is very important point to remember for in the point of view of MCQ, in the point of view of maybe some interesting questions that might come in your JEE or KCET exam. Now, in a non-polar molecule, the centers of positive and negative charges coincide. We discussed previously also, again we are discussing. This is a very point of MCQ questions. In case of non-polar molecule, that nothing is given, option A, B, C are given. The centers of positive and negative coincide, center of positive and negative does not coincide, center of positive and negative stay a long distance apart, like that. So, you have to understand that in case of non-polar molecule, centers do coincide, and in case of polar molecule, the centers do not coincide. So, they have a permanent dipole moment. Permanent, there is no permanent dipole moment for non-polar, there is a permanent dipole moment for polar. Okay. Examples of non-polar are oxygen, hydrogen, etc. Okay. Example of polar are HCl, H2O, carbon monoxide. You can relate it from your chemistry chapters. There are few polar molecules, right. So, all the polar molecules are basically can be considered as this polar molecules. In chemistry and physics, same thing. Okay, only thing the direction is different, slight property wise we chemistry is they treat it something differently than we treat. So, our main property interest in the electrical properties, their main property interest in the chemical properties, right. So, that is the major difference. Otherwise, if you read something is polar in chemistry, the same thing can be written here also, they are also polar. Okay, but do not write too much complicated examples in physics exam if they ask you some examples, because physics teachers are not super familiar with all that complicated names, but common names are okay. Next, in an external electric field, the positive and negative charges of non-polar molecules are displaced in opposite direction. So, obviously, what happens when you apply the external electric field, positive and negative, their centers, it's for example, this is a non-polar molecule. Okay. In case of non-polar molecules, positive and negative, they coincide together. Now, in the presence of external field, positive and negative, they slightly separates. Okay, they separate slightly and they try to oppose the external electric field, and this happens for non-polar molecules also. In case of non-polar molecules, as you can see, positive and negative, they are randomly oriented. So, total even though they have a molecular permanent dipole moment, the total dipole moment of the material is 0. But in the presence of external electric field, based on the strength of the external electric field, they align themselves according to the electric field and they try to cancel the external electric field, but they have a limitation, they cannot cancel the entire external electric field. Okay. Now, this is another important term. This term is very important for MCQ as well as any competitive exams that you might be preparing for. The dipole moment per unit volume is called polarization. So, they might say polarization is dipole moment per unit volume, dipole moment per unit area, dipole moment per unit length, like that. So, this is also a important term. This is also electric polarization. There is another polarization you have learned in light and optics chapter, in wave optics chapter, but this is electric polarization. Electric polarization is slightly different than that of optical polarization, right. The dipole moment per unit volume is called polarization and is denoted by capital P, and P is equal to epsilon naught chi e into E. Here chi e is a constant and of the dielectric and is known as the electric susceptibility. Very interesting, very important. Don't confuse this with magnetic susceptibility. This is electric susceptibility, and epsilon naught is the free space permittivity, E is electric field, and P is the polarization. So, once I think in the question, previous year question, I see there is a problem based on this formula, okay, and that is a KCET. For KCET, there is a problem came from this formula. Okay, they have given you values and you have to put and calculate P like that, or you have to calculate E. Okay, I don't remember, but there is a question based on this. Now, again, you can skip remaining part. The polarized dielectric is equivalent to two charged surfaces with induced surface charge density, say sigma p and minus sigma p. Clearly, the field produced by these surface charges opposes the external field. The total field in the dielectric is thereby reduced from the case when no dielectric is present. Suppose there is an electric field. If you insert an electric field, what happens to the electric field in that region? The electric field in that region reduces but does not become 0. This is also a point of an MCQ question. So, there is a region of space, electric field region, where a dielectric is placed. The electric field inside the dielectric will be completely 0, will be reduced slightly, will increase like that. So, they will give you like these options. So, you have to choose the correct option, that electric field reduces slightly or reduces, only reduces. Okay, slightly or more, that we do not know based on the property of the dielectric. It can be more, it can be less, but obviously it will reduce. Now, next part, the most important, capacitors and capacitance. So, capacitors and capacitance, you can read all these text that is given here, but main part is this Q is equal to CV or C is equal to Q by V. So, capacitance is a device which is used to store charges. So, we need to know how much charge it can store. So, capacitance is defined by Q by V. Okay. Now, a capacitor with fixed capacitance is symbolically shown as this symbol, parallel plate symbol, while the one with variable capacitance is shown as this variable symbol. Also, you have to remember that the total charge of the capacitance is 0, even though we say the charge on a capacitor. If I say charge on a capacitor, generally that represents only Q. Okay, capacitor generally has two charges, plus Q and minus Q. Okay, they always combine in a pair. Okay, and charge on a capacitor, if I say, that is Q, but only positive is considered. But total charge, when you say total charge, you have to consider the total positive and negative charge. So, total charge of a capacitor is 0. So, that is also a question came in the previous year. So, that is why I mentioned it. The maximum electric field a dielectric medium can withstand without breakdown is called its dielectric strength. So, what happens is that, suppose you are keep on adding charges to this plates. Okay, there are two plates that is being used to store charges, capacitor. Okay, so there is a dielectric medium between these two plates. So, when there is a dielectric medium between these two plates, for example, air is also a dielectric medium. Okay, it is a non-polar dielectric medium. So, you can consider air is also a non-polar dielectric medium. So, as long as you are adding charges, these charges are keep on attracting each other, right? Opposite charges always attracting each other. So, after certain voltage, what happens? All the electrons stored in the negative plate quickly comes from negative plate to positive plate and neutralize all the positive charges. This is called the breakdown. Once the breakdown happens, the capacitor can get burned because of the very high amount of heat energy developed. So, that is why your battery, your mobile battery, your laptop battery, or whatever, phone battery, watch battery, whatever you are using, they have a limit. Okay, they cannot charge completely beyond certain limit. If you charge your mobile, if you actually there is a defensive mechanism that prohibits you to overcharge your mobile, but if you overcharge your mobile beyond certain value, then definitely all the positive charges and negative charges will come towards each other and they will destroy your battery. Okay, which is a kind of capacitor, not exact capacitor, but similar principles. They also work on the similar principle. Right. So, there is a positive terminal, there is a negative terminal, and they have some charges. Okay. If you overcharge your battery, but after some time what will happen? Your battery will burst. Okay, your battery will burn. Similarly, if you keep on charging your capacitor, okay, ideal capacitors even after breakdown also you can use it, but capacitors are not ideal, not everything is ideal, right. So, what happens is that when it reaches a certain value, okay, all the charges of the negative terminal comes through that dielectric, okay, forces through the dielectric because of the high voltage, and they reach to the positive side, destroying all the charge that you have stored. That is called the dielectric strength. Okay. So, this is called dielectric strength. That is also important for your fill in the blanks question. Okay, dielectric strength is the maximum charge it can store without breakdown. Okay. And for air it is 3 into 10 to the power of 6 volt per meter. So, this is the electric field, the value of electric field 3 into 10 to the power of 6 volt per meter is the maximum air capacitor can hold. You can increase this value using different types of dielectric material. There is a limit to the amount of charge that can be stored on a given capacitor without significant leaking. Okay, that part is called leaking. Okay, there will be small leaking every time, but if you cross that limit, then definitely it will leak in an instant, but small leaking is possible. So, this is also an important point for objective question. The parallel plate capacitor. In the parallel plate capacitor, the derivation of parallel plate capacitor capacitance is very important. Okay, so if you start from here, okay, outer region 1 is 0, outer region 2 is 0, inner region 3. So, inner region is whatever is in the inner region, then after that you have to come here and explain that voltage is V is equal to E into D, and from there you have to put the value of E that you have calculated. From there again you have to define that capacitance is defined by Q by V. So, you have to put the value of V here, then calculate it, you will get epsilon naught A by D. And effect of dielectric in a capacitance, is the capacitance increases as you add a dielectric medium between the capacitance. Okay. Now, based on different applications, there are different questions may come, especially if you are preparing for JEE mains exam, but that is not part of this lecture because they are not covered in NCERT. So, I am not going to discuss how you can place different dielectrics in series, parallel, etc. So, you have to solve them. Right, the series is Decode NCERT. So, we are only discussing NCERT. Now, capacitors, combination of capacitors, it is also important, not only the formulas, but also the derivation, especially combination in capacitors in series, very important derivation. I have done this derivation, you can check that, and if you are following from NCERT, then you have to start here. Explain the parts, obviously slightly, what is V1, V2, what is C1, C2, Q, why Q is same in series combination, that you have to explain properly. Then you can apply this, and then this is the formula for two capacitors in series combination. Okay, this is the general formula for two capacitors in series. And if you are preparing for competitive exam, then you should remember when two capacitors are connected in series, obviously this is C1 C2 by C1 plus C2. This is the shortcut formula, directly calculate the values. Otherwise, I have seen students using this formula, but at the end moment they forgot to take the inverse. Okay, because it is 1 by C, so you have to take the inverse to calculate C. So, they are calculating 2/3, 1/3, whatever value they are getting, but they have to take the inverse. So, if the answer was 2/3, then it final answer will be 3 by 2, that is 1.5, but they are mistaking it. Okay, so they are leaving it at 2/3 and thinking, okay, I have done correctly. So, they are losing marks, and in competitive examination they are scoring negative marks as well, right. Now, in series is parallel is very easy, especially for capacitors. Okay, this is just addition of all the capacitance. So, simply you can find that this is easy. And what else? Energy stored in a capacitor. Now, energy stored in a capacitor came only once in your Karnataka PU board exam. Okay, and that was also a substitute exam. That means, if you failed in the first exam, in the second or third exams, I think second exam, third exam only started from the last year. So, previously you get a chance, if you failed in the exam, you can appear for another improvement exam. So, that time this derivation came only once, otherwise I have not seen this, but the formula is important for KCET exam. Okay, so if you are preparing for KCET exam, the work done is basically q square by 2c or half cv square, very important, or half qv. These three expressions can be, if you know q is equal to cv, then you can definitely convert from one to another. Half cv square is the most common, but based on the given values, sometimes it is beneficial for if you use q square by 2c directly to calculate the values, or half qv to calculate directly. Half cv square, even though you can convert all the forms, but based on the requirement, if you remember all the forms directly, then it will save at least 5-10 seconds. That's it. Okay. And energy stored in the capacitor is given by U is equal to half epsilon naught AD, and energy density is given by U is equal to half epsilon naught E square. That is also possible in KCET exam. So, we have completed this chapter in 2 halves. Okay, and summary you can read once. Summary part, I have already summarized the chapter, and you can read the summary part once more if you wish to. And this table is very important. This table is important to remember all the dimensions, okay, especially for competitive exams. And nowadays I am seeing some questions in your PU board also, they are asking match the dimensions. So, this is also possible in your PU board exam. Okay, so we have completed this chapter completely. If you have any doubt, any questions, don't forget to mention that in the comment below. I will be back with more lectures in future. Friday will be Brahmastra last chapter, electromagnetic waves, and then in the night we will be back with a new chapter, current electricity. Till then, bye.